Hello everybody, welcome to test 4 review. We really don't have a test 4, but this will cover pretty much everything between test 3 and the final. As always, the formula on that side and the topics that we cover be on the top. Right. So first, classify conics. Sorry, there was something going on. Somebody called me in the middle, so I have to stop the video in the middle while I already have this stuff down. Anyway, so to classify conics, the equation like this, only the coefficient for x squared, xy, and y squared are important, and we find the discriminant. Remember that. Notice that d is not really this d, so that's confusing. So let's change that to delta. And if it is less than 0, ellipse equal to 0, parabola. Hyperbola will be greater than 0. Hyper meaning is greater than 0. I mean that makes sense. Anyway, so a equal to 1 or the first one, b equal to 10 and c equal to 25. Put in the formula that equal to 0 is parabola. Same thing on the next one. So b squared minus 4ac, and we have that less than 0, so that ellipse. So yeah, just change that to something else other than d, because that will be redundant with the formula here. Right. Next, we really don't have this in that topic, but I'm going to do that anyway. So first, what we look at this, we see 2 and 2 and 2. So why don't we divide 2 on the top and bottom? So when we do that, we have r equal to 1 over 1 minus cosine theta. Right. Cross multiply here. We should have r one minus cosine theta equal to 1. Now multiply it out, we have r minus r cosine theta equal to 1. The objective here, because we're going to turn that into a rectangular equation, so pretty much these are the formula we can use. X is r cosine theta, y is r sine theta, and x squared plus y squared equal to r squared. So here we have r cosine theta, so that will be x. So we have r minus x equal to 1. Right. Now next is a tricky part. We're going to somehow turn the r into x and y. The only thing we can do is r squared is equal to x squared plus y squared. So we're going to add x on this side. So we have r equal to x plus 1. So I will add 1 on both sides. I mean add x on both sides. Sorry. And after that, I can square both sides. And square will be x squared plus 2x plus 1. Right? And move the x squared over. But first, all we can use x squared is r squared is x squared plus y squared. And we cancel that on both sides. Yeah. The second problem will be kind of like that, but let's omit it. Right. So when we change to rectangular equation, we can use that. Right. Next, on the final, we might have something like that when we change to rectangular equation, but not this complicated. Right, next we go to rectangular from parametric equation. So we have this. So what we see is we either solve for t we can solve for t for either x or y, it doesn't matter. So I probably will solve for x, because when you substitute in here you have y equal to something. That will be better. So if x equal to 3t, all we need to do is divide everything by 3, and we'll have t equal to right. And we substitute t equal to x over 3 into this. So we'll just have y equal to t plus 3 will be y equal to x over 3 plus 3. So that's pretty simple there. The only thing we need to worry about is this. So let's write that again. So that's what we have. Now, in order to have t is equal to x over 3, so I will substitute x over 3 like that, and multiply everything by 3. And I will have x between 9 and negative 6. Right. So that's what we have. So yeah, we either solve for t from x or for y, and then substitute into the other equation, and finally try to find the range for that as well. Right. Next, this is completely different, because if we solve for t, it will involve the inverse, and substitute in it, that will be a mess. So instead of that, what we do is I will divide by 4 on both sides here. And I'll do the same thing for the other equation. Right, doesn't help much. However, if we square both sides, we have x squared over 4 squared, y squared over 4 squared, square, of course. And then if we add side by side, x squared over 4 squared plus y squared over 4 squared equal to 1. This is an ellipse, or more specifically, it is a circle. So we just multiply 4 squared on both sides, or we have x squared plus y squared equal to 16 if we multiply 16 on both sides. Right, and t go from 0 to 2 pi, so this will complete one revolution. So all we have, can multiply by 16 to get that. It doesn't matter. Right, so if we draw an ellipse, would be 4 up, 4 down, 4 left, 4 right. So that's pretty much just a circle. So for that circle, we can say x is between negative 4 and 4, and so is y. So the parametric equation usually we go with the domain for the variable, so we should have the domain for either x or y. Right, so that's the question. Right, so usually when we have sine, cosine, the only way to eliminate the parameter t, the best way is to somehow get the sine, cosine by itself, square them, and add them. We eliminate the t. That way will be the most efficient. Right. Now we have the other way around. When we have the parametric equation, and now we have the equation like this, and then we turn to parametric equation. So this will be, for that one is easy. For this one, not so much. For this one, if we let x equal to t, then y equal to 2t minus 5. This is almost still easy, because when x equal to t, and that's 2t minus 5, just like that. The only thing we need to specify is the domain for t. So since we do not have anything here, we just say t is any numbers, so we should say that. Yeah, because there's no restriction for x and y, so it should be that. Alright, next, parametric equation that move along the ellipse. I try to sketch this ellipse. 8 unit left and right, and 9 unit up and down. So this 8 and 9, and ellipse go like this. And we go from a and 0, 8, and go clockwise. Right. Actually, let's ignore this condition. Just assume that somehow we get the ellipse. That would be fine. So it will get very complicated later. So for now, we have x squared over 64 plus y squared 81 equal to 1. Yeah. So kind of like this. We know that somehow we have to turn to compare that to cosine square and sine square equal to 1. If we have the condition here, that could be tricky. But let us assume that, let's ignore that condition. In that case, it will be a lot easier. Then we just say one of them is cosine and one of them is sine. We can mismatch if we want to. But let's say x squared over 64 is equal cosine square. So taking the square root on both sides, we have x over 8 equal to cosine theta. So multiply by 8, x equal a cosine theta. Y squared over 81 equal to sine square. I will take the square root as well. We have y over 9 equal to sine theta. So y equal to 9 sine theta. Right, so we have x and y. If we did not specify the speed, how fast it go around, and that would be easy. We can just generically say go from 0 to 2 pi, or we can go more than 0 to 2 pi if we want to go around it many times. But generically, we can just say from 0 to 2 pi. Yeah, if we do have that condition, then we might not have enough space to do that problem here. All right. So next we have partial fraction. So for this we should have the calculator, because there will be a lot of system of equation. I'm going to put the calculator there. Alright, so first problem. Now we have two factors here. Two factors there. So we'll have a factor of x minus 2 and then x minus 4. On the top we have less degree than the bottom, so we have a and b. Right. Multiply both sides by the common denominator. That we will have x minus 12 equal to a x minus 4 plus b x minus 2. Multiply it out. Ax minus 4a plus bx minus 2b, and then group the coefficients ax, bx. We have a plus b, where we factor out an x, and this right. So like that. Next, what we do is we just match the coefficient, meaning that this one go with x must match with this. The coefficient must be the same. Therefore, a plus b must be equal to 1. And then that coefficient must be equal to this coefficient. So the same power terms, we have the same coefficient. That is what we call the undetermined coefficient. Right, now we'll go to this. Right, great. This calculator doesn't have that F, so I have to switch to my own calculator. Right. So I go to apps. Look for we can also solve using matrix, but let's do this. So go again, polynomial. I will go back to that later. So simultaneous equation. Right. This we have two variables and two unknowns. So we have two equations, two unknowns. Just give a fraction and go next. The coefficient is 1 for a, 1b, 1, and negative 4 for a, negative 2 for b, and negative 12. When we solve, we have 5 and negative 4. So let's go back to that app again. Alright, it will be in polynomial simultaneous equation. Right, that one. Polynomial root finder. Sorry, not that. The second option, simultaneous equation. Right, so, and we just keep doing that. Right, now since a is 5 and b is -4, we put it back into this form. We have 5 over x minus 2 plus -4 over x minus 4. That is the partial fraction. Right. I will do a lot more of this, of course. Right, so that was 10. Right. Now the idea of this, if we just have the linear factors, then on the top the power have to be less than that, meaning that we do not have any x on the top. So be just like that. Multiply by the common denominator, combine like terms, and then matching the coefficient. So it will be like what we just did. Next, we go to 12 instead. Right, for 12. The difference in this problem is that we have the x plus 1 square, meaning that we have the repeated factor. If it is repeated, we have to increase the power from 1 to 2. If this is a cube, we're going to have one more, x plus 1 cube, and then higher power. We just go from first power, second power, third power until we match that power. Now that is a, over here we just b, and even though this has the square, will be just have the same form as this, so will be just c and not cx plus b, just c. Right, and then the same way multiply by the common denominators. Right, I will speed up on this one. So we have that. Right, we have a 1 of x plus 2, we will have x plus 1 and x plus 2. We have x plus 1 already, so we will have x plus 2 square and x plus 2 square cancel. Right, multiply it out. I'll skip a few steps here. Alright, and then multiply it out. Right, combine like terms. X square, that's it. Now the x. Three a, 4b, and a c for x. And then 2a, 4b, and c. and that must be equal to the left hand side of negative 4x squared minus 14x minus 15. Right. So now we just match the coefficient. Match for x squared with that, meaning a plus b must be negative 4. Negative 14x must be equal to this. So 3a, 4b, and c is negative 14. And the last one equal to negative 15 is this. Right. Now back to the calculator. So we go to that screen. This time 3 equation, 3 unknown. Right, now the coefficient. Right. We have 1 for A, 1 for B, no C, negative 4. Notice negative is this negative sign and not that subtract. And then 3, 4, 1, negative 14, 2, 4, 1, negative 15, and then so. Right. X is 1. X of course is 8, so we have A is 1, sorry, B is negative 5, and C 3. So put it back into a original equation. We have 1 over x plus 2, negative 5 over x plus 1, and 3 over x plus 1 squared. Right. For some reason it go back to the coefficient. I apologize, this should be x plus 1. Yeah, I should not rush this one. Wait. Yeah, I got them backward. Sorry. Let me try this again. Right. Let's do this instead. We will multiply x plus 2, x plus 1 square. In that case, we will not miss anything. x plus 2 x plus 1 square. Right, much better. The whole thing cancel here. Yes, I should do that at the first place. So x plus 2 cancel. One of the x plus 1 cancel. Sorry, this was a square. Right, so right. So that one and that was a square. So the square cancel. We just see an x plus 2. Right. Now multiply it out. Right. Multiply it out. Right. Combine like terms. This is square. That is the square. For the x's, 2ax, 3bx, and cx. And then we have a and 2c and 2b, of course. Right, so we match AB, we match with 4x squared, negative 14x. We match that with this, and the negative 15. We match with that. So let's write the equation. A plus B, some space. Back to this system of equation, we have 1, 1, negative 4, 2, 3, 1, negative 14, 1, 2, 2, negative 15, negative 3, negative 1, and negative 5. Right. Sorry about that. We should have just multiplied the least common denominator like this and cancel what is missing. I should not speed up that step. So A is negative 3, B is negative 1, and C is x plus 1 squared. So yeah, so just multiply to the least common denominator and cancel what is missing. We should have that. Also note when we have the repeated factor, then we just have that and then that factor square, and then if we have more like the cube, then we will have one more for cube. Right. Right. Next, we have this with a quadratic factor. So it only have two factors, so it makes sense if we just have this. Now, on the top, the power on the top must be less than the bottom. This bottom have only x, so the top have no x. This bottom is x squared, so the top will have 1 power less. We cannot have more or equal power of x on the top than the bottom. Right. Now the least common denominator is this. Now we just do like we did last time. It's better just be careful with this common denominator. Right. That cancel. This cancel. And the whole thing cancel. So we have that. And then we'll just multiply it out. Combine like terms. Except, sorry, this problem we have a already. This will be different coefficient. So instead of a and b, so let's change this to b and c. All the coefficient must be different. Right. At least this one we haven't gone very far. So it should be b and c. Sorry about that. So all the coefficients must be different. Right. Now we multiply it out. Ax squared plus ax plus a, and then bx times x, bx squared, bx times 1 negative bx plus cx minus c. Right. Combine like terms. Ax squared and bx squared. We have x squared ax negative bx and cx. So a minus b and c x. And finally, for constant we have a and negative c. Now we just match a coefficient a plus b. Since there's no x squared here, we're going to put 0x squared and make that equal to 0. A minus b plus c equal to 10, and a minus c equal to 2. Right. Right. The coefficient 1 for a, 0, 1 for b, 0 for c, and 0 there. 1, negative 1, 1, and 10, 1, 0, negative 1, and 2. Right, we have 4, negative 4, and 2. And put it back into this form, we will have 4 over x minus 1 plus negative 4x plus 2 over x squared plus x plus 1. Right. This problem I will not do it, but I at least will give the form. We have the x squared plus 5, but repeat it. since this is a square, so we have two of them. We're going to have two of them. One with the first, one with the second, because we only have two of them. On the top, we just put ax plus b, and then this have to be different coefficient. So we have that. Right, so that is partial fraction. Next, arithmetic sequence and geometric sequence. This is just like course algebra. The formula will be on that side. That is the topic. We have some question that is not in that topic, but we go over that here as well. So write the first four terms. So that will be easy. A1, put 1 in here. And that we have 4 factorial will be 24. By the way, the factorial, when we hit math, sorry, turn it on. Math option, go to the probability tab. Under that probability tab, option number 4. Yeah, but we should hit the number first. So 4 math. Yeah. And then A2, we're going to put 2 in for n. And you can continue for A2, A3, A4. They want the first 4 terms, so we're going to need 4 of them. Right. This part is easy, so we have A1 already. We will go to A2. If we put 2 here and here, 2 minus 1 is A1 plus 3. So we're going to have 7. Except I forgot the 4 here. So in that case, that is 19. Right. Next, A3, I'm going to put 3 in for n. Three minus 1 is 2. Where A2 is 19 plus 3. 4 times 19, 76. 3 is 79. And the same thing for A4. Four minus 1 is A3 plus 3. We'll just do that. Right. Express the sum using summation notation. Right. Have from 2 to 8, all of them are even. So we will have a sum. This is go with corresponding with the index will be 1. This will go with 2. This is 9. So we go from 9 from 1 to 9, and each time we will have 2 times that. Right. Right. Next, what we see is that the top is 2 more than the bottom. say that backwards, sorry. The bottom is 2 more than the top. And we go from the first term to 13, so there will be 13 of them. And the top, the bottom is 2 more than the top. Right, we will do this in class. Right. Now on to arithmetic sequence and geometric sequence. The formulas over there. Let me change that a little. Yeah, that is better. Now, that we cover pretty much everything there. Right. So very straightforward. Arithmetic sequence. In general will be that, and we just have a is the first term, so we have 7 plus n minus 1 times d negative 7. So pretty much that. And if we want the 13th term, we're going to put 13 in for n, and whatever that is. I have negative 77. We can just leave it like that. That's perfectly fine. If we want to, we can also multiply it out. Negative 7n plus 7 or negative 7n plus 14. That's perfectly fine. Right. So arithmetic sequence, we have that formula, and those formula you will have on the test as well. So worry too much about that. This 23rd term, arithmetic sequence, we start with this is the first term. To get from the first to the second and to the second to third, we need to add 6 to get from this to the next and this to the next. So an equal to a1 plus n minus 1d, and we want 23rd term. The first is 0, 23, 1, and difference is 6, and we have that. Right. So we have the 10th term and the 16th term. Right. In general, we have the same formula. And then we're going to use those information. Put 10 in for n. 10 minus 1 so will be 9d. And that's supposed to be equal to negative 12. If we put 16 in for n, we still have that. 16 minus 1 will be 15d equal to negative 24. We have this system of equation. What we do is like we did with on the partial fraction, the system of equation. We have 6 and negative 2. So the first term is 6 and d is -2, right? So pretty much that. Oh, so we have the first term is 6. To get to the next term, we're going to have this term -2. So the previous term -2 to get to the next term. Right. Sorry, I have to pause the video right now and I'll continue in a minute. Right, I'm back. Right, so take a look on the formula. So both of them with formula for the nth term. We start from the first term, a1. Both of them have a1. And arithmetic, we're going to take n-1 step, and this step we multiply by d. So have a1 plus n-1 d. Also we have n-1 in the geometric sequence, but instead of add, we're going to multiply, and instead of multiply, we go to power. So there's some relation there, right? And the sum formula will be that, but of course the proof for that, I think we will do that in class. Anyway, so once again, the formula for the nth term in an arithmetic sequence is that, and everything will based on that formula. Right. Now the sum, we can, or with either of this formula, but we do need to know the first term. That we know. This we ask for the sum, so we know the first term is -6. We also know that to get to the next term, we look like we have to add 5 to it. Add 5 to go from this term to the next. So difference, common difference is 5. Right. That's all we know. Next, in the formula for the sum, either we have to know the nth term, or at least we have to know the number of terms. So we need to find n. So we know that the nth term is going to be 39. So again, we use the same formula we have earlier. And I've just put 39 in for the an. We don't know what n is. We do know the first term, and the difference is 5. Right? Multiply it out. 39 minus 6 plus 5n minus 5. Minus 6 minus 5, that's minus 11. Add to the other side. So we have 50 equal to 5n. So n equal to 10. So we have total of 10 terms. Next could be easy. Now we know the number of terms. N minus 1 d. There's nothing there. Sorry. The number of terms is 10 over 2. 2 times the first term plus the 10 terms minus 1. the difference, common difference is 5. I'll just do that. Right, so that will be 5, negative 12, and that's 9 and 5 will be 45. 45 minus 12, 33 times 5, 165. Right. So for the sum, we need to have the number of terms, the first terms, the difference, because n number of terms is there. If we do know the last term, instead of, we can also set the first term plus the last term. I mean, we use this first formula. Yeah. That also works. I'm going to write over here instead. We know there are 10 terms. The first term is negative 6, and then 39 for the nth term. Do that, we should get the same thing. So the first term and the difference, usually we know those. Just need the number of terms, or sometimes we know the nth term, that we use that. That works just fine. So either of them is fine. I might need to change adjust the focus a little bit. Just kind of. Yeah, that's a little bit better. Right. I'll look at the next problem as well. The total of 14 steps. So we know that 14 steps. At the bottom we require 101. Each one will be one less. How many bricks required? Right. So 14 steps. So that will be n. The first one, 101. And each one will have one less. And then you can put in that formula, and that's pretty much it. Yeah, substitute everything in that formula, we should have it. Alright, so that is arithmetic sequence. We have from 21 to 25. Right, geometric sequence. I tried to highlight only the columns on the right, but I couldn't. So anyway, we focus on the right column. Right, but pretty straightforward. We want the 26th, and we want the 9th term. In general, it's that formula. So we want the 9th term. The first one is 5. The ratio 3 to the n minus 1. There's 9 for n. And so 5 times 3 to the 8th power. Right. Right, 5 times 3 to the 8th power. 32,805. That is the formula for the arithmetic sequence. This is for the geometric sequence. Right. This the same thing. We just need to determine how the sequence is formed. So the first one, the first term -2, to go from this to the next and this to the next and so forth. The ratio, we need to multiply by 3, so that the ratio is 3. So in general we have the nth term, the first times r to the n minus 1. So the first term we know is -2 and the ratio is 3 to the n minus 1. So pretty much that. The sum formula, again, straightforward. Sorry, the n on the top. So either we can use either formula. I'm using the first one, the first formula here. Yeah, either of those formula is fine. So the first term is 2. To get to the next, we need to multiply by 2. So that is the ratio is 2. And this one, the first 11 term, so n is 11. And we just put everything in here. 2 for the first term times 1 minus the ratio is 2 to 11 over 1 minus 2. And that's just the calculator work. Right, next, this is the infinite geometric series, a little bit different. That will be the one in the last. Yeah. Pretty much that. So the first term in the series is -30. And to go from this to the next, pretty much we have to divide backwards. So -6 divided by -30 is 1/5. That is the ratio. So to find the ratio, we just divide it backwards, just like this. 4 divided by 2, 8 divided by 4, 16 divided by 8. The same way here, -6 divided by -30, that's divided by -6, just divide backward, and we should have it. So it's 1/5. It's very important that the ratio must be over there, must be less than 1, meaning that required to have r is between 1 and -1 to have a sum. If we don't have this, we do not have a sum. In this case, 1/5 is between -1 and 1, and the sum is equal to a1, 1 minus r. a1 is -30, and 1 minus 1/5. Right? I will multiply 5 top and bottom. So I have -130, and then 5 minus 1 will be 130 over 4. Look like it can reduce by 2. 150, I don't know why, right? 130, sorry. 75 over 2. Right. So as long as the ratio, common ratio, has to be between -1 and 1, we have the sum like that. If the ratio is not between -1 and 1, meaning if it is greater than or equal to 1 or less than or equal to -1, then that sum does not exist. or we say divergent. Right. Same thing here. The first term is 1/4, and I'll go to the calculator here. Right, I divide backwards, so negative 1/4, I mean 1/2 divided by 1/4. The common ratio is negative 2. So the next one would be negative 2, and then plus 4, and then so on. So it will be like that. Right. Since the ratio is between negative, it's not between negative 1 and 1, so this one is divergent, or if we say divergence, meaning the sum does not exist. Because the R is bigger than R is less than negative 2, less than negative 1. Right. Have to be between negative 1 and 1. This one doesn't. Right. So we just like that. The next one we can also do the same way. We can write like that, or 0.45 plus 0.0045 plus 0.000045. You get the idea. When we add this up, we will have that, which is 45.45 repeating. And so in this sequence, I will not do it, but I just write out the first term is 2.45, and the ratio, we need to divide it backward. Calculator. 0.0045 divided by 0.045, that would be 0.01. Right, and then we just do S and sorry, no N, A1 over 1 minus R, A1 over 1 minus R. So we have 0.45 over 0.99. Move the decimal point, we will have 45 over 99, and that reduced by 9. Have 5 over 11. Right. The next one I will not do it, but look like the first term is 9, and 1/3 of the distance fallen, so it's 1/3, and then you can fill out the rest of the problem. Right. So that is geometric sequence. Will be a little bit more than that. We have the nth term is this, we have the sum, and we have the infinite geometric series, but only when r is between negative 1 and 1. So we have those things. Next we have mathematical induction. Right, this is a proof. So let's look at the first one. Induction, we have 3 parts. First, we check to see if it is true for n equal to 1. And this should be the case, otherwise we say that is false and we don't need to prove anything, right? So when n equal to 1, we're going to put 1 in here, and that's all we have on the left hand side. I'm going to put 1 in for n. So the left hand side is 3, the right hand side is 6 divided by 2 is 3. So yes, that check. So it is true with n equal to 1. I need to change the contrast again a little bright. I think that might be a little better. Right. The next step, we assume that it is true for every n. I mean for k. For n equal to k, actually. Meaning that we're going to do this 3 plus 8 plus dot 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 plus 5k minus 2 equal to k over 2, 5k plus 1. We'll not do anything. That is our assumption. So we assume that is true. So we will not prove it. We just say that is true. Right. Next, we will prove that it will be true for n equal to k plus 1. This is the main part of the proof. So the left hand side will copy it again, 3 plus 8 plus dot dot dot. Right. First, it will go up to this term. We're going to write that term as well. But this time it is, we have an extra term of when n equal to k plus 1. So we, rather than up to this one, we're going to add one more term. And that term is 5 of k plus 1 minus 2. Alright, so pretty much we put k plus 1 in here. That will be the last term. We add to this sum. Alright, so that's the left side. The right side, instead of k plus 2, we have k plus 1 over 2. And then this 5k plus 1 plus 1. Right. Now, what we're trying to do is we're trying to make somehow turn the left hand side equal to something like that. Right. So, in order to do that, I will multiply this out first. The left hand side is still the same though. I will not do anything with the left hand side. But this, I will split. I will have k over 2 and 1/2. And I multiply this out and combine. I will have 5k plus 5 plus 1 will be plus 6. I would just say plus 1 and then I will add 5 to it. Right. What I try to do is try to have the k minus 2, k over 2 here, and the 5k plus 1. Now I multiply that. The left hand side is still the same. Like I said, on this one I will not do anything on the left hand side. Maybe a bit later, but for now. Multiply the two purple part together. Those two, we have k over 2, 5k plus 1. And that gives us 5k over 2 and then 1/2 5k plus 1 plus 5/2. Right. Next, notice that this is the purple part. It's exactly like that, which by assumption will be true for all of the things in this box. So those two are equal because that is our assumption. So we can pretty much cross that out, or we subtract on both sides, either way. And then I will multiply it out, and we have 5k. 5 times 1 is 5 minus 2 plus 3. So left side is 5k plus 3. On this side I will have 5k over 2 plus 5k over 2 plus 1/2 plus 5/2. 5k over 2 plus 5k over 2, that is 5k, and 1/2 5/2 is 3. And that is true, so we prove it. So the main part of mathematical induction is this part. The first one is always should be true when n equal to 1 or any initial value. This is our assumption. So with that assumption, we will add one more term. When n equal k plus 1, we add one more term to it. So this is what we're going to add to it. And we're going to add 1 into k, add 1 into k into that. Now, we try to manufacture the same thing as this, so that we cross out on both sides, and then the remaining part must be equal. We will not have enough space for 34, so I will omit it. We should have it some time in class to do a few more of this, but that is the principle of mathematical induction. Yeah, we can also multiply this out, but I don't need to do that. Right. So with that, we should cover everything needed for the review. As mentioned before, this is only the part between the test 3 and the final. To review for the final, you need to go over all 4 reviews like this. I hope it helped, and good luck on your final.